I'm now going to derive a few equations that would be useful when we do problems on simple harmonic motion. Now, I'll start from these two formulae that I have obtained. One for x as sine omega t and the other one for v as cosine omega t. I'm going to start by writing out the three formulae. Now the first one is this: is that v maximum velocity is equal to omega times the amplitude. That's one. Now the next one, v is equal to plus or minus omega times square root of a squared minus x squared. And the third one is a formula for the period. So the time for one cycle of the motion, meaning if you start from the rest position, we go up, come down, and go back to the rest position. That's one cycle. So the time for this, the period t is equal to 2 pi over omega. So let's now take a look at each of these and see how they come about. Right, the first one, V max is omega times A. How does this come about? Well, this one is quite simple. It comes from this equation. Right. If I have so V is equal to this number times cosine omega. Now the number in front of the cosine function would give the maximum value for V. Okay, so that's why the maximum V is just omega A. So it's something that we can just read from this equation, right? The reason is that the biggest value of cosine omega is 1 and the smallest value is minus 1. So because the biggest value for cosine omega is 1, so the biggest value when you multiply by omega A is just 1 times omega A. So that's why we have this. So with this equation, we can actually find the maximum velocity if we know the amplitude of the simple harmonic motion and omega. We will talk about how to find omega later on for specific examples of the spring and the pendulum. Now next, if I look at number 2 relates the velocity at any point, right? The velocity at any point of the motion. 2 is displacement. So that means that, let's say I don't have that let's say I know that equation, and if I know the time, I would be able to use this equation to calculate the V. But what if I, instead of the time, what if I don't know the time but I know the displacement? Because after all, I can follow this displacement with my eye, and maybe I can measure a particular position with a ruler. So I can find the displacement directly. So if I know the displacement, how do I find the velocity? And well, this is how I can find it. I can use this formula just by substituting the displacement into this formula. But of course, I must know the amplitude and I must know omega. And with this, I can calculate V. But why plus or minus? Why plus or minus? Right? Because in this formula, because of the nature of this formula, when I substitute x inside here, whether I substitute a positive x or if the ball is below the rest position, it will be a negative x. Inside the formula, I have to take x squared, which means that the sine of x would be cancelled. Okay, so therefore I need this plus or minus sign because it is possible that the x is either up there or down here. So the velocity can be not only that, even if it is for a single positive x, even if it's for a positive value of x, okay, it is possible to have two directions of the v, because the ball can, when the ball moves up to there, it is on its way up, so the v is upwards. But after passing that position, going up and then coming back down again, it will come back to the same value of x, but this time it would be on its way down. So even for the same value of x, it is possible to have the velocity either going up or going down. Okay, so that's why we also need this plus or minus sign in the formula, because if we just specify the value of x alone, we would not be able to tell whether from this information alone whether the v is going up or down. So the plus or minus just tells us that either one is possible. And finally, if we want to find the period of the motion, we would take 2 pi over omega. Now if you look at this expression, this equation for the simple harmonic motion, it's not obvious why I should take 2 pi over omega. It's just an abstract equation. But if we go to this circular motion, remember that we have explained how the circular motion can be related to simple harmonic motion simply by looking at the vertical displacements of the ball in circular motion. Now, if you look at this, we have already seen that the omega here is actually corresponds to the angular velocity in this circular motion, in this corresponding circular motion. Okay, and we know how to find the time it takes for the ball to go one round, okay, to go one cycle, if you like, in a circular motion. We can simply get that from the angular velocity, because, right, why is that? Because angular velocity, as you know, is angular displacement divided by time. So if I want the time, right, in the special case, when the time is 1 period, that means the ball has gone 1 round. When time is 1 period, the angle would be 360 degrees. Now in this case, we must use radian, so that would be 2 pi. And when you rearrange this, you get this expression for the period.